A syllogism is a kind of logical argument that applies deductive reasoning to arrive at a conclusion based on two or more propositions that are asserted or assumed to be true. In its earliest form, defined by Aristotle, from the combination of a general statement and a specific statement, a conclusion is deduced. For example, knowing that all men are mortal and that Socrates is a man, we may validly conclude that Socrates is mortal. Syllogistic arguments are usually represented in a three-line form: all men are mortal. Socrates is a man. Therefore, Socrates is mortal. The word therefore is usually either omitted or replaced by the symbol a. Early history: in antiquity, two rival theories of the syllogism existed, Aristotelian syllogistic and Stoic syllogistic. Aristotle defines the syllogism as a discourse in which certain things having been supposed, something different from the things supposed results of necessity because these things are so. Despite this very general definition, in Aristotle's work Prior Analytics, he limits himself to categorical syllogisms that consist of three categorical propositions. These include categorical modal syllogisms. From the Middle Ages onwards, categorical syllogism and syllogism were usually used interchangeably. This article is concerned only with this traditional use. The syllogism was at the core of traditional deductive reasoning, where facts are determined by combining existing statements, in contrast to inductive reasoning where facts are determined by repeated observations. Within academic contexts, the syllogism was superseded by first-order predicate logic following the work of Gottlob Frege, in particular his Begriffsschrift, but syllogisms remain useful in some circumstances, and for general audience introductions to logic. Aristotle: the use of syllogisms as a tool for understanding can be dated back to the logical reasoning discussions of Aristotle. Prior to the mid-12th century, medieval logicians were only familiar with a portion of Aristotle's works, including titles such as Categories and On Interpretation, works that contributed heavily to the prevailing Old Logic, or Logica Vetus. The onset of a new logic, or Logica Nova, arose alongside the reappearance of Prior Analytics, the work in which Aristotle develops his theory of the syllogism. Prior Analytics, upon rediscovery, was instantly regarded by logicians as a closed and complete body of doctrine, leaving very little for thinkers of the day to debate and reorganize. Aristotle's theories on the syllogism for assertoric sentences was considered especially remarkable, with only small systematic changes occurring to the concept over time. This theory of the syllogism would not enter the context of the more comprehensive logic of consequence until logic began to be reworked in general in the mid-14th century by the likes of John Buridan. Aristotle's Prior Analytics did not, however, incorporate such a comprehensive theory on the modal syllogism, a syllogism that has at least one modalized premise. Aristotle's terminology in this aspect of his theory was deemed vague and in many cases unclear, even contradicting some of his statements from On Interpretation. His original assertions on this specific component of the theory were left up to a considerable amount of conversation, resulting in a wide array of solutions put forth by commentators of the day. The system for modal syllogisms laid forth by Aristotle would ultimately be deemed unfit for practical use, and would be replaced by new distinctions and new theories altogether. Medieval scholarship: Boethius contributed an effort to make the ancient Aristotelian logic more accessible. While his Latin translation of Prior Analytics went primarily unused before the 12th century, his textbooks on the categorical syllogism were central to expanding the syllogistic discussion. Boethius' logical legacy lay not in any addition he personally made to the field, but rather in his effective transmission of prior theories to later logicians, as well as his clear and primarily accurate presentations of Aristotle's contributions. Peter Abelard, another of medieval logic's first contributors from the Latin West, Peter Abelard gave his own thorough evaluation of the syllogism concept and accompanying theory in the Dialectica, a discussion of logic based on Boethius' commentaries and monographs. His perspective on syllogisms can be found in other works as well, such as Logica Ingredientibus. With the help of Abelard's distinction between didicto-modal sentences and aremodal sentences, medieval logicians began to shape a more coherent concept of Aristotle's modal syllogism model. John Buridan, considered by some to be the foremost logician of the later Middle Ages, John Buridan contributed two significant works, Treatise on Consequence and Summuli de Dialectica, in which he discussed the concept of the syllogism, its components and distinctions, and ways to make use of the tool to expand its logical capability. For the next 200 years after Buridan's discussions, little would be said about syllogistic logic. It has been assessed by historians of logic that the primary changes that occurred in the post-Middle Age era were changes in respect to the public's awareness of original sources, a lessening of appreciation for the logic's sophistication and complexity, and an increase in logical ignorance, an ignorance that would be heavily ridiculed by logicians of the early 20th century. Basic structure: a categorical syllogism consists of three parts: major premise, minor premise, conclusion. Each part is a categorical proposition, and each categorical proposition contains two categorical terms. In Aristotle, each of the premises is in the form all A are B, some A are B, no A are B, or some A are not B, where A is one term and B is another. All A are B, and no A are B are termed universal propositions. Some A are B, and some A are not B are termed particular propositions. More modern logicians allow some variation. Each of the premises has one term in common with the conclusion. In a major premise, this is the major term. In a minor premise, it is the minor term of the conclusion. For example, major premise: all humans are mortal. Minor premise: all Greeks are humans. Conclusion: all Greeks are mortal. Each of the three distinct terms represents a category. In the above example, humans, mortal, and Greeks. Mortal is the major term, Greeks the minor term. The premises also have one term in common with each other, which is known as the middle term. In this example, humans. Both of the premises are universal, as is the conclusion. Major premise: all mortals die. Minor premise: all men are mortals. Conclusion: all men die. Here, the major term is die, the minor term is men, and the middle term is mortals. Again, both premises are universal, hence so is the conclusion. Assertions is a form of argument in which a series of incomplete syllogisms is so arranged that the predicate of each premise forms the subject of the next until the subject of the first is joined with the predicate of the last in the conclusion. For example, if one argues that a given number of grains of sand does not make a heap and that an additional grain does not either, then to conclude that no additional amount of sand would make a heap is to construct a Assert's argument. Types of syllogism. There are infinitely many possible syllogisms, but only 256 logically distinct types and only 24 valid types. A syllogism takes the form: major premise: all M are P, minor premise: all S are M, conclusion: all S are P. Note: MA middle, SA subject, PA predicate. See below for more detailed explanation. The premises and conclusion of a syllogism can be any of four types, which are labeled by letters as follows. The meaning of the letters is given by the table. In analytics, Aristotle mostly uses the letters A, B and C as term placeholders, rather than giving concrete examples, an innovation at the time. It is traditional to use as rather than as the copula, hence all A as B rather than all as a BS. It is traditional and convenient practice to use a, E, I, O as infix operators so the categorical statements can be written succinctly. The letter S is the subject of the conclusion, P is the predicate of the conclusion, and M is the middle term. The major premise links M with P and the minor premise links M with S. However, the middle term can be either the subject or the predicate of each premise where it appears. The differing positions of the major, minor, and middle terms gives rise to another classification of syllogisms known as the figure. Given that in each case the conclusion is SP, the four figures are. Note, however, that, following Aristotle's treatment of the figures, some logicians for example, Peter Abelard and John Buridan reject the fourth figure as a figure distinct from the first. See entry on the prior analytics. Putting it all together, there are 256 possible types of syllogisms. Each premise and the conclusion can be of type A, E, I or O, and the syllogism can be any of the four figures. A syllogism can be described briefly by giving the letters for the premises and conclusion followed by the number for the figure. For example, the syllogism Barbara below is AAA1, or AAA in the first figure. The vast majority of the 256 possible forms of syllogism are invalid. The table below shows the valid forms. Even some of these are sometimes considered to commit the existential fallacy, meaning they are invalid if they mention an empty category. These controversial patterns are marked in italics. All but four of the patterns in italics are weakened moods, that is, it is possible to draw a stronger conclusion from the premises. The letters A, E, I, O have been used since the medieval schools to form mnemonic names for the forms as follows: Barbara stands for AAA, Celarent for EAE, etc. Next to each premise and conclusion is a shorthand description of the sentence. So in AAI3, the premise all squares are rectangles becomes map. The symbols mean that the first term is the middle term, the second term is the predicate of the conclusion, and the relationship between the two terms is labeled A. The following table shows all syllogisms that are essentially different. The similar syllogisms share actually the same premises, just written in a different way. For example, some pets are kittens could also be written as some kittens are pets. In the Venn diagrams, the black areas indicate no elements, and the red areas indicate at least one element. Examples: Barbara, AA all men are mortal. AA all Greeks are men. All Greeks are mortal. Celarent, similar, se, AA no reptiles have fur. AA all snakes are reptiles. No snakes have fur. Daria, similar, dartizi, AA all rabbits have fur. AA some pets are rabbits. Some pets have fur. Virio, similar, festino, furizon, frasizon, AA no homework is fun. AA some reading is homework. Some reading is not fun. Barocco, AA all informative things are useful. AA some websites are not useful. Some websites are not informative. Bocado, AA some cats have no tails. AA all cats are mammals. Some mammals have no tails. Barbari, AA all men are mortal. AA all Greeks are men. Some Greeks are mortal. Celarent, similar, Cicero, AA no reptiles have fur. AA all snakes are reptiles. Some snakes have no fur. Camestros, similar, Calamos, AA all horses have hooves. AA no humans have hooves. Some humans are not horses. Flapton, similar, Fasapo, AA no flowers are animals. AA all flowers are plants. Some plants are not animals. Darapti, AA all squares are rectangles. AA all squares are rhombuses. Some rhombuses are rectangles. Table of all syllogisms. This table shows all 24 valid syllogisms, represented by Venn diagrams. Syllogisms of the same type are in the same row, and very similar syllogisms are in the same column. Syllogisms with affirmative conclusions are on the left side, those with negative conclusions on the right side. Terms in syllogism: we may, with Aristotle, distinguish singular terms such as Socrates and general terms such as Greeks. Aristotle further distinguished terms that could be the subject of predication, and terms that could be predicated of others by the use of the copula. In Aristotle's view, singular terms were of type and general terms of type. Thus men can be predicated of Socrates, but Socrates cannot be predicated of anything. Therefore, for a term to be interchangeably to be either in the subject or predicate position of a proposition in a syllogism the terms must be general terms, or categorical terms as they came to be called. Consequently, the propositions of a syllogism should be categorical propositions, and syllogisms that employ only categorical terms came to be called categorical syllogisms. It is clear that nothing would prevent a singular term occurring in a syllogism so long as it was always in the subject position however, such a syllogism, even if valid, is not a categorical syllogism. An example is Socrates is a man, all men are mortal, therefore Socrates is mortal. Intuitively this is as valid as all Greeks are men, all men are mortal, therefore all Greeks are mortals. To argue that its validity can be explained by the theory of syllogism would require that we show that Socrates is a man is the equivalent of a categorical proposition. It can be argued Socrates is a man is equivalent to all that are identical to Socrates are men, so our non-categorical syllogism can be justified by use of the equivalents above and then citing Barbara. Existential import: if a statement includes a term such that the statement is false if the term has no instances, then the statement is said to have existential import with respect to the term. In particular, a universal statement of the form all A is B has existential import with respect to A if all A is B is false when there are no as. The following problems arise. A. In natural language and normal use, which statements of the forms all A is B, no A is B, some A is B and some A is not B have existential import and with respect to which terms? B. In the four forms of categorical statements used in syllogism, which statements of the form all B, AEB, IB and AOB have existential import and with respect to which terms? C. What existential imports must the forms all B, AEB, IB and AOB have for the square of opposition be valid? D. What existential imports must the forms all B, AEB, IB and AOB have to preserve the validity of the traditionally valid forms of syllogisms? E. Are the existential imports required to satisfy above such that the normal uses in natural languages of the forms all A is B, no A is B, some A is B and some A is not B are intuitively and fairly reflected by the categorical statements of forms Ahab, Abe, Ale and Alb? For example, if it is accepted that IB is false if there are no As and all B entails IB, then IB has existential import with respect to A, and so does all B. Further, if it is accepted that IB entails BA, then IB and all B have existential import with respect to B as well. Similarly, if AOB is false if there are no As, and AEB entails AOB, and AEB entails B then both AEB and AOB have existential import with respect to both A and B. It follows immediately that all universal categorical statements have existential import with respect to both terms. If all B and AEB is a fair representation of the use of statements in normal natural language of all A is B and no A is B respectively, then the following example consequences arise. All flying horses are mythological is false if there are no flying horses. If no men are fire-eating rabbits is true, then there are fire-eating rabbits is true, and so on. If it is ruled that no universal statement has existential import then the square of opposition fails in several respects and a number of syllogisms are no longer valid. These problems and paradoxes arise in both natural language statements and statements in syllogism form because of ambiguity, in particular ambiguity with respect to all. If Fred claims all his books were Pulitzer Prize winners, is Fred claiming that he wrote any books? If not, then is what he claims true? Suppose Jane says none of her friends are poor. Is that true if she has no friends? The first-order predicate calculus avoids such ambiguity by using formulae that carry no existential import with respect to universal statements. Existential claims must be explicitly stated. Thus, natural language statements of the forms all A is B, no A is B, some A is B, and some A is not bar can be represented in first-order predicate calculus in which any existential import with respect to terms A and or B is either explicit or not made at all. Consequently, the four forms all B, AEB, IB, and AOB can be represented in first-order predicate in every combination of existential import so it can establish which construal, if any, preserves the square of opposition and the validity of the traditionally valid syllogism. Strawson claims such a construal is possible, but the results are such that, in his view, the answer to question above is no. Syllogism in the history of logic. The Aristotelian syllogism dominated Western philosophical thought for many centuries. In the 17th century, Sir Francis Bacon rejected the idea of syllogism as being the best way to draw conclusions in nature. Instead, Bacon proposed a more inductive approach to the observation of nature, which involves experimentation and leads to discovering and building on axioms to create a more general conclusion. In the 19th century, modifications to syllogism were incorporated to deal with disjunctive and conditional statements. Kant famously claimed, in Logic, that logic was the one completed science, and that Aristotelian logic more or less included everything about logic there was to know. Though there were alternative systems of logic such as Avicennian logic or Indian logic elsewhere, Kant's opinion stood unchallenged in the West until 1879 when Frege published his Begriffsschrift. This introduced a calculus, a method of representing categorical statements and statements that are not provided for in syllogism as well by the use of quantifiers and variables. This led to the rapid development of sentential logic and first-order predicate logic, subsuming syllogistic reasoning, which was, therefore, after 2,000 years, suddenly considered obsolete by many. The Aristotelian system is explicated in modern fora of academia primarily in introductory material and historical study. One notable exception to this modern relegation is the continued application of Aristotelian logic by officials of the Congregation for the Doctrine of the Faith, and the Apostolic Tribunal of the Roman Rota, which still requires that arguments crafted by advocates be presented in syllogistic format. Boole's acceptance of Aristotle. George Boole's unwavering acceptance of Aristotle's logic is emphasized by the historian of logic John Corcoran in an accessible introduction to Laws of Thought. Corcoran also wrote a point-by-point comparison of prior analytics and laws of thought. According to Corcoran, Boole fully accepted and endorsed Aristotle's logic. Boole's goals were to go under, over, and beyond Aristotle's logic by 1, providing it with mathematical foundations involving equations, 2, extending the class of problems it could treat. Solving equations was added to assessing validity, and 3, expanding the range of applications it could handle. For example, from propositions having only 2 terms to those having arbitrarily many. More specifically, Boole agreed with what Aristotle said. Boole's disagreements, if they might be called that, concern what Aristotle did not say. First, in the realm of foundations, Boole reduced Aristotle's 4 propositional forms to 1 form, the form of equations. By itself a revolutionary idea. Second, in the realm of logic's problems, Boole's addition of equation solving to logic. Another revolutionary idea involved Boole's doctrine that Aristotle's rules of inference must be supplemented by rules for equation solving. Third, in the realm of applications, Boole's system could handle multi-term propositions and arguments, whereas Aristotle could handle only 2-termed subject-predicate propositions and arguments. For example, Aristotle's system could not deduce no quadrangle that is a square is a rectangle that is a rhombus from no square that is a quadrangle is a rhombus that is a rectangle, or from no rhombus that is a rectangle is a square that is a quadrangle. Syllogistic fallacies. People often make mistakes when reasoning syllogistically. For instance, from the premises some A are B, some B are C, people tend to come to a definitive conclusion that therefore some A are C. However, this does not follow according to the rules of classical logic. For instance, while some cats are black things, and some black things are televisions, it does not follow from the parameters that some cats are televisions. This is because in the structure of the syllogism invoked the middle term is not distributed in either the major premise or in the minor premise, a pattern called the fallacy of the undistributed middle. Determining the validity of a syllogism involves determining the distribution of each term in each statement, meaning whether all members of that term are accounted for. In simple syllogistic patterns, the fallacies of invalid patterns are, undistributed middle, neither of the premises accounts for all members of the middle term, which consequently fails to link the major and minor term. Illicit treatment of the major term, the conclusion implicates all members of the major term. However, the major premise does not account for them all. Illicit treatment of the minor term, same as above, but for the minor term and minor premise. Exclusive premises, both premises are negative, meaning no link is established between the major and minor terms. Affirmative conclusion from a negative premise, if either premise is negative, the conclusion must also be. Negative conclusion from affirmative premises, if both premises are affirmative, the conclusion must also be. Existential fallacy, this is a more controversial one. If both premises are universal, that is, all, or no statements, One school of thought says they do not imply the existence of any members of the terms. In this case, the conclusion cannot be existential. That is, beginning with some. Another school of thought says that affirmative statements do imply the subject's existence, but negatives do not. A third school of thought says that the any type of proposition may or may not involve the subject's existence, and though this may condition the conclusion, it does not affect the form of the syllogism. See also argumentation theory, Buddhist logic, enthymem, other types of syllogism, disjunctive syllogism, hypothetical syllogism, polysyllogism, prosleptic syllogism, quasi-syllogism, statistical syllogism. Syllogistic fallacy, the false subtlety of the four syllogistic figures, Venn diagram, notes. References, Aristotle, Prior Analytics Transl. Robin Smith ISBN 0-87220-064-7, Blackburn, Simon, 1996. Syllogism in the Oxford Dictionary of Philosophy. Oxford University Press. ISBN 0-19-283134-8. Brawdy, Alexander, 1993. Introduction to Medieval Logic. Oxford University Press. ISBN 0-19-824026-0. Irving Cope, 1969. Introduction to Logic, 3rd ed. Macmillan Company. John Corcoran, 1972. Completeness of an Ancient Logic, Journal of Symbolic Logic 37, 696 702. John Corcoran, 1994. The Founding of Logic. Modern Interpretations of Aristotle's Logic, Ancient Philosophy 14, 9 24. Hamblin, Charles L., 1970. Fallacies, Methuen, London, ISBN 0-416-70070-5. Cf. on Validity of Syllogisms. A simple set of rules of validity was finally produced in the later Middle Ages, based on the concept of distribution. Jan Angstrom Łukasiewicz, 1987. Aristotle's Syllogistic from the Standpoint of Modern Formal Logic. New York, Garland Publishers. ISBN 0-8240-6924-2. OCLC 15015545. Porzig, Gar 1/4 NTER 1968. Aristotle's Theory of the Syllogism, a logico-philological study of Book A of the Prior Analytics. Reidel, Dordt. Smiley, Timothy 1973. What is a Syllogism? Journal of Philosophical Logic 2, 136 154. Smith, Robin 1986. Immediate Propositions and Aristotle's Proof Theory. Ancient Philosophy 6, 47 68. External links, Aristotle's Logic entry by Robin Smith in the Stanford Encyclopedia of Philosophy, the Traditional Square of Opposition entry by Terence Parsons in the Stanford Encyclopedia of Philosophy, Medieval Theories of the Syllogism entry by Henrik Lagerlund in the Stanford Encyclopedia of Philosophy, Aristotle's Prior Analytics, The Theory of Categorical Syllogism, an annotated bibliography on Aristotle's Syllogistic, Abbreviatio Montana, article by Professor J. Kilcullen of Macquarie University on the medieval classification of syllogisms. The Figures of the Syllogism is a brief table listing the forms of the syllogism. Interactive Syllogistic Machine, a web-based syllogistic machine for exploring fallacies, figures, and modes of syllogisms. Crystal Tower, examples of syllogisms, syllogistic reasoning in Buddhism, example and worksheet, fuzzy syllogistic system, development of fuzzy syllogistic algorithms and applications, distributed reasoning approaches, comparison between the Aristotelian syllogism and the Indian Tibetan syllogism, the Buddhist philosophy of universal flux,